All right, I think we're going to start off there. It's 2 minutes past. We're waiting on one extra person, but I'm sure they will be able to join. So I'm just going to do a quick intro about what we're doing here today, and then I'll move it to Philip, who will be kind of taking over the rest of the session until we finish up. So thanks everyone for joining today. What we're doing is a show and tell on the Golem Network hackathon that just wrapped up, which was essentially our first hackathon for the mainnet release of our beta 1 for Golem Network. It was super interesting to see what people came up with. It had a total of 5 categories. So we had the main open track category. We had Golem on DeFi, gaming on Golem, and Golem plus MIT Solve for social good, and also Hack Golem. So for the Hack Golem category, the winner was R34X, or sometimes known as R4X in the Discord. So he created Windows subsystem for Linux. So it essentially allows Windows users to run Golem within WSL, kind of removing the need for virtual machine on Windows, which was a pretty cool hack. One of the other winners was the gaming on Golem category. So that was the HSOG requester, which is Hearthstone on Golem, which kind of helps the Hearthstone community in designing and building decks to run on a large number of simulated games on the Golem network, which was created by Chris Helms. So for the Golem and MIT Solve for social good category, it went to photogrammetry, which is 3D scanning. So it's an online IDE which lets you run Micmac for photogrammetry workloads on the Golem network. For the open track, the winners were, so we had Golem AFL by Sladislav, I think it is, which is a experimental test fuzzing framework for Golem. It kind of helps you find security holes in your software, and it's more for testing, which is quite handy. So it kind of adds to the tools that are available for developers to use. Secondly, there was the CNN Predict service on top of Golem by a community member Reza, who's quite active. So it's a deep learning application that distributes popular CNNs pre-trained with ImageNet datasets across Golem provider nodes. He's not able to present today along with a few others, but we're excited to have the people presenting anyway. And so the next 2 winners for the open track was also the Hearthstone requester and the 3D scanning on Golem. So without further ado, I think I'll move it on to Philip, who will be introducing some of the people that will be doing the show and tell today.
Thank you. Yes, so the first presentation we're going to have will be done by Shardul, who's presenting his Golem photogrammetry. So if you're ready, you can take the scene.
Hi, Shardul here, and I was the developer behind Golem photogrammetry. So it's a tool which lets you convert 2D images, a set of 2D images, into 3D models, which you can use in virtual reality, in gaming, and various applications. So I'll be sharing my screen. So okay, is it visible?
Yes, we see it.
Okay, So it's an online IDE where you can put Micmac shell scripts and you upload the files, the image files, and so it runs a batch job. So what happens is that this Golem, this process, photogrammetry takes time. So this specific workload, it takes around 20 to 30 minutes. So yeah, so I made a design decision that instead of making the user wait here, the person will get an email which contains the files, and then you need to put the file. So I'll be showing you all the contents afterwards. So this is it. This is buddha.zip. So we'll be putting different images of a Buddha idol, and then we'll get the 3D image. Then you press the submit button, and so it starts working. So as you can see, this Golem is running in my IDE. So this is the node server which runs the front end. So we can see that the shell script has been broken down into individual commands, and then the job will be posted on the Golem network. So basically, this is how. So I'll be showing you the file. So this is what we are sending to the software. So we can see there are these different images taken from different angles. Okay, and besides this, we have some hyperparameter files because computers, we need to tell them like from which different angles the images have been taken, what resolution we require, all that. So all of this was packaged in a zip file. So once this is done, we get an email. So whether the build was successful or it failed, and you can press the download button, and you'll get the result. So right now, as of now, it's the build is still happening, but this is a screenshot of the finished product. So this is a viewer file which lets you view such 3D images. So this was the 3D model. We could rotate it in different angles. We could change the color like that. And this is Micmac is it's a very low level programming framework on top of which different companies have built their proprietary user interfaces. So you can check, if you search Google for Micmac, you will get all the you'll get the documentation. So these are all the scripts. So we were using Apero. If we look at the script, so Tapioca, Apero. So these are the tools used for parsing. And so so as of now the workload, so the job runs in a serial fashion. So like so currently it's processing the images one after another in a but like the code can be optimized to run to process each individual image on a different Golem server. So this was the demo. I guess we could move forward, have some Q&A and such.
Okay, thank you for the presentation. It's a very nice project. So congratulations on winning. I have a few questions if you don't mind.
Thanks a lot. Yeah.
My first question is, how did you come up with the project? Is it something you run yourself on a daily basis and you maybe thought that Golem could help you save some time with?
Well, it was I used to play some games earlier, and I watched a gaming trailer recently. I provided the reference in the project GitHub repository. So it's a game where they scanned the entire area of the Chernobyl nuclear reactor, and they made a game out of it. So I felt it was pretty cool. So and the hackathon happened to be at the same time. So there was a connection.
That's really cool because, as a matter of fact, Shardul, our product team also came up with a similar idea. So it was actually, like you said, right moment, right time. Congrats.
Yeah. Thanks a lot.
Yes, that's very cool. So basically, you're just able to insert the output files as assets into a video game, right?
Yeah.
Nice. That's very nice. I don't know if we have any other questions. Do we have some from the community, Costanza?
I could ask some.
Okay.
I'm actually not that familiar with telemetry and how it works and everything like that, but you said it runs for 30 minutes. So whenever you create your like Golem providers, like what exactly is going on there? Are you creating like does each provider handle some kind of frame or some kind of like part of the calculation, or is it how is the end result broken up into multiple providers or parallel computing?
Okay, so like since it was a hackathon, my submission it has some rough edges. So it's running, it's running the entire job on one provider. Okay, it's not currently optimized to run on different nodes, but if you look at the script, so these are the things. So it's running 3 commands: this tapioca and apero. So let me take a look. I just kind of forgot. So
Yeah, sure.
tapioca. Okay, so the tapioca says it's an interface for tie point detection and matching. So tie point is like a common point between multiple images. So tapioca, it generates some XML files which contains some data, which is in turn used by the next tool. So we detect the tie points using tapioca, and then apero, it's so according to it says it computes external and internal orientations. So I guess this is something about like getting the directions and such, and then the final command micmac converts it into a 3D into a mesh file. So it's a the files end with .ply polygon something. So it's a 3D format for photogrammetry. But this micmac is a suite of some 20-30 tools. So it's very specialized. It's used with drones, like generating terrain imagery and such.
Okay, gotcha. Yeah, thank you.
Okay, so it doesn't look like there's any questions from the community so far. So I guess we can move on. So thank you.
I wouldn't mind asking a quick question
Okay,
just before.
sure.
So do you have any ideas of maybe how you could maybe expand the project a little bit or continue to progress? Have you thought at all about that so far?
Yeah, of course. In the short term, in the medium term, the code can be optimized, but like to actually take it to the market. So there's an open source front end like a GUI which makes all this thing like the photogrammetry a bit easier. So it's like it's a more complex thing. Like we could like change the source code and like instead of using regular micmac, we could integrate it with Golem micmac. So I believe it is possible, but it's like it's a bit complex.
Yeah, I understand. Okay, cool. Thanks.
Okay, any other questions? Nope. Okay. I guess we can move on then. Thank you for the presentation, Sharton. It was very nice.
Thanks a lot. Take care.
You too. Well, okay. Next up is Chris, who made a Hearthstone simulator for his card decks. So take it away.
Yeah, sure thing. I'm going to keep mine fairly casual, and I'll admit I was up late last night for an install, so feel free to ask any questions, and sorry if I stumble over some words. So I'll share the screen. This is the presentation I made for it previously, and then I think I submitted as part of it. So you can check back here for any details. I'm going to kind of move over this and do a little glossing over it, but this will have a little more kind of in-depth stuff. And again, feel free to ask any questions. So mine was Hearthstone simulations on Golem. And essentially what the idea is that I think in the DAO channel on the Discord, someone was mentioning how we need to reach out to different communities and give them ways to access Golem or give them ways to utilize Golem. I play a lot of video games, and I work with a lot of people who play video games and everything like that, and a lot of them are into these online card games. And so I kind of came up with this idea around Hearthstone. So in case you don't know what it is, Hearthstone's a popular online card community, and Blizzard created it. There's quite a few players that play it. They build decks, they fight them against each other, and that's pretty much how the game goes. Within those decks, there's different cards, and then you want to apply strategies to those cards to play them in the best way possible. And so the idea is, how can we utilize the Golem network in a way that can pull that in and help Hearthstone community? So the idea overall is that we can create a replication of Hearthstone, the game, and that we can run that as many times as possible. Since a game of Hearthstone may take a person, take 10 to 15 minutes, if we could give them the ability to play, 300 or 500 over the course of a couple minutes, that might be useful. And so what they'd want to get out of that would be statistics on those cards, statistics on their deck, how their deck performs, their win rate, all those kinds of things. So without getting too tangential, in Hearthstone, whenever you build a deck, you may want it to do certain things. So I think the example in here I use is a mill deck. And a mill deck typically forces your opponent to discard their cards until they have none left. And then Hearthstone basically takes their life away and kills them. So the idea of a mill deck is just basically making your opponent discard their cards. And the idea of a mill deck, or the statistics we want to see on that, would be how many cards have they discarded, how many cards have they had to play, how many cards we force them to draw, all that kind of thing. And so we can consider those statistics when we design this application. And so the overall idea is that we create a Docker container that can simulate a game of Hearthstone, and then we use Golem and the Golem requester to run that simulation hundreds of times on the Golem network and grab the statistics from that. And so that's kind of what the execution is. I might have skipped over that. But essentially what we're going to give this is two decks, our deck and the opponent's deck. And those decks are going to consist of cards that we've decided to be in the deck. And then we're going to tell it two strategies. And I'll get into that in a second. So there's four parts of that provider piece. So you can imagine there's kind of four parts to the overall Hearthstone simulation. There's the game engine, and that's basically the logic that's built into Hearthstone. So if you were to go play a game of Hearthstone, you would do things like draw cards, play cards on the field, use monsters to attack each other, those sorts of things. That's what the game engine handles, all that kind of basic Hearthstone logic. And then we have cards as another section. So cards are just like cards in Hearthstone. They have like health and mana and all this sort of stuff, and they're representative of kind of these logical ideas and things like that. And so cards is another part. Strategies is what you would apply to the cards in the game engine to actually play the game. So while the game engine allows us to play a card, or it allows us to draw a card, a strategy is actually what decides or makes those decisions for us. That was a little difficult for me to implement, but I'll get into that in a second. And then finally, we have logging. So logging is actually what gets us the useful statistics out of the simulation itself. That's the thing that's going to be tracking, like how many cards you played, how many monsters you've attacked, how much damage you've taken, who wins, all those sorts of things, and gives you useful output at the end of the simulation. So for the game engine overview, there's like a game flow of Hearthstone. It's pretty basic. You decide who goes first, who goes second. They take turns drawing cards, playing monsters, fighting each other, and in the end, someone dies and the winner is determined. That's essentially what the game engine does at a high level. Obviously, there's a little more detail in there, but overall, that's essentially how it functions. And then, as we said before, the game engine provides the logic for the mechanics in Hearthstone. So essentially, the game engine mocks Hearthstone. I tried to go through and make sure that everything Hearthstone could do, the game engine could do. I maybe missed a couple of edge cases, especially when some cards got complicated. But as of now, it's fairly simple to build a deck, draw cards from your deck, play them on the field, play spells, cast them, all that kind of stuff. So that's all the game engine's job. Cards are a little more depth of the game engine. So if you're not familiar with Hearthstone, there's two kinds of cards. You have a monster card, which is something you play and attack with and stuff like that onto the field. And then you have a spell card. And typically a spell card has some kind of effect on the game. Maybe it removes a monster out of the game, or maybe it just directly does damage or something like that. But what you kind of get into is a little more detailed facets of the game engine. So cards have a cost that you have to play them. They do certain damage. They have certain health. And a lot of them have these attributes or effects, which I'll get into in a second. But this is what makes things a little more complex. So, for example, Stone Tusk Boar has charge, and that means he can attack as soon as you play him, whereas other cards may not be able to do that. With spell cards, you see that they're pretty much entirely based on their effect, and they typically get a little more complicated. So here we're choosing like a monster, and we shuffle 3 copies of it into our deck. And that's what a spell does. So a spell pretty much is focused on just an effect there. So that's the interesting thing about implementing cards is they get very complex, especially spell cards. So this card I have on the left that says I am very complicated. Every time you play a card, this transforms into a copy of it. So you kind of have to base your entire game loop or game logic around being able to handle these card logics because they get quite complicated, and your game engine might not be designed to handle, all of the offense that one of these can put out. And so that's essentially what this slide says, is that some cards are very simple, like monster cards that just attack and do damage and stuff like that, but some get very complex with the events they do. And so to solve that issue, I defined a series of interfaces that you can apply when building these cards that helps the game recognize what cards are capable of. So for example, if we had some kind of spell that you have to choose a monster to do damage to, that spell may be a targeter interface. And so a targeter maybe can get a list of targetables or things they can apply to, and then you can set which one you want to target, and then whenever you play it, it applies it to that target. And so the interfaces kind of help out with the whole card logic and configuration of them. Some cards can be configured at the very beginning of the game. So for example, maybe a card, when you play it, gives you health back. Maybe it adds 5 health or something like that. We already have all the information at the beginning of the game to perform that action. We can set, me as the card's target, and we already know it's going to apply 5 health at some point. So we can configure that in the beginning. Where some cards that are more complex have to be configured during playtime and involve more complex decisions that a strategy would have to make. So for example, maybe it needs to knock a monster off the field, or maybe it needs to give an attack buff to some monster. Those things can get more complicated, and we don't have that information necessarily at the very beginning of the game. And so that's a decision we have to make then. And that's what this preparation is about. So cards that have these interfaces typically have to be prepared in some way or configured in some way, either at the beginning or during the game, so that they act correctly when being played. That's where strategies come in. So strategy is kind of complicated because you have this game engine that can do things, and you have these cards that are being played as kind of data. But the strategy in the end has to make the decision as to how to play things, and you have to give it a capability to play things. So the strategy is essentially the brain behind the player moves within the simulations. I've included 2 strategies here. So there's a dumb strategy and a simple strategy. And dumb strategy plays a random valid move, and simple strategy maybe makes some very simple considerations and then plays a move. But overall, a strategy I was able to kind of pull out as an interface without getting too technical here. Essentially what a strategy does is receive a set of possible moves from the game engine, and then it chooses the next move and selects that and gives it back to the game engine. So what that kind of suggests there is that the game engine itself had to have a capability design where it can look at the current state of the game and pick all the possible moves for a player to make. It then hands all those possible moves over to the strategy, and the strategy can look through them, the info included, and choose the best one for the current situation. That move is made, and then that loop continues. The game hands it the next valid possible moves, and it plays the next move. So that's kind of what a strategy does there. I feel like I'm underselling that because it took me a while to design, but that's essentially the process. So we can maybe consider some situations where there are a ton of moves, which is kind of interesting to run into. So for example, if you play a card and the card has an effect, or a better one might be if you have a monster on the field and that monster wants to attack someone, the opponent could have 4 different monsters for our monster to attack. So maybe we could say that's 4 valid moves for our monster, right? But then what if whenever our monster attacks, there's some effect on the card that says, oh, you have to choose someone to take additional damage or something like that. So we run into a combination there. So we can attack 4 monsters, but then for every monster that we attack, we can also choose another monster to do damage to. And so you can see that the number of moves grows fairly large fairly quickly. But whenever these moves are passed to the strategy, they're passed with some additional info, and so that gives the strategy the ability to look deeply into the moves to consider which one's the best for its current idea. Finally, we get to the less exciting part, which is logging. So actions throughout the game produce logging to the console, which is pretty simple, right? So things like if a monster attacks or if we do damage to a player, that's all written out to a logging file into the console. So if you were to go and look at that logging file afterwards, you could see exactly how the game was played, what monsters attacked what monsters, who died, what effects were happening, all that kind of stuff. We also track statistics on using an event system. So if a monster were to attack something, that triggers an event that's fired and somewhere else catches that event, and it's logged as X monster attacked Y monster for Z damage. And we keep all that and track it in a big set of statistics that we later utilize. So these are examples. The game logging on the left here, and you might not be able to see it, so I'm going to zoom in real quick or not. Interestingly enough, when I zoom in on Chrome, it zooms out. But over here on the left, I hope you can see it. You can see kind of the game turns being printed out here, so we can see player 1 is taking their turn. Their mana is being increased, they drew a loot hoarder, and so on and so forth. So you can see kind of the game flow on this left file game logging. In the center, we have the statistical output of a single game. So this is kind of the output, or all the events that were recorded in that game in one file. You can see here at the top, this player was using the dumb strategy. The cards that were drawn were 23. They were forced to draw 2 more cards. They didn't discard any cards, so on and so forth, with things like monster damage, monsters lost, damage to their hero, mana use, all that kind of stuff. So we track that for each player. And then we also track, obviously, the winner of the game. And then finally, there's a final report. So this goes back to kind of the requester side of things. So we have all these providers running these different simulations of the game, and they all provide their statistical output. And then in the very end, once all those simulations have been run, the requester combines them all together and creates that final report of all the kind of aggregated statistics. So the layout of this may look a little confusing, but for example, in cards naturally drawn, we have 3 numbers. It's just a min, average, and a max. And so that applies to all of these statistics. So you'll get a min, average, and a max of all of them back out in the very end. I think that's about the overview of all of it. I'm happy to answer any questions. It got a little complicated, but yeah, I think that's a pretty good overview of the application.
Thanks a lot for the presentation. It was very in-depth, and it for sure helps with people like me who doesn't play Hearthstone myself, so it helps a lot. If you are ready to move into questions, I have a few ones to start out with, and then we can see if someone in the community has one. So my first question is simulating decks in Hearthstone a common thing, and is there other types of solutions like this in the wild, or?
I'm gonna be honest, Philip, I have no idea. I looked it up and I didn't find any simulation stuff out there for Hearthstone. So I assume, but I know that there's definitely websites that let you like build decks and stuff like that, but I don't think they let you test them in a way that this would. So I'm gonna say no, but then again, I could be lying.
That's totally okay. We'll just say you're the first one then. And secondly, so in the demo, you simulated a total of 20 games, I think it was. But is there any specific minimum amount of simulations to run before the output's accuracy can be trusted?
I don't actually know that. And funnily enough, my girlfriend is biostats. She's heavily in statistics. So I did not guess a number where we could say, okay, this is a good number of statistics to run and say, hey, these are valid statistics. Because obviously, like you're saying, with 5 games, we could get something biased or something like that. But no, I didn't set a lower limit to that. I hadn't actually focused that much on the statistical analysis of the games.
Okay, fair enough. Okay, do we have any questions from anyone else?
I can't see any from the community, but I'm a little bit interested. First off, thank you for the presentation. That was super interesting. I was just wondering, so have you tried out your Golem decks in real life? And if so, how have they gone, or have you shared them with anyone else to try out?
I have not yet, no. Actually, what's interesting about this is that I have to go through and define the cards myself. So you see that I can, like whenever I define a card, I can kind of look at other cards and say this is similar, and it'll use similar interfaces, or I can reuse interfaces like the targeter one I talked about. But implementing cards takes me a little bit, just because sometimes you'll come across a card that maybe has some effects or some kind of action that I hadn't yet thought of. And so I have to go and pull it in or create an interface for it. Cards can kind of be defined that way quickly, but sometimes you do have some that take a little more thinking or time to implement. So I think currently I have like 30 cards or so defined. I would need to go through and define a good bit more before I think this is useful in the real world or to someone who's actually playing Hearthstone right now. So it'll be a little bit of time before this is actually useful to someone playing right now, because there's hundreds of Hearthstone cards and one of me.
Yeah, fair enough. That'd be super interesting though. So if you do end up trying it out, I'd be very interested to see.
I actually have a question because I thought it was a very cool project. I'm super happy with all the projects in this hackathon. And I actually had to look up Hearthstone because I've never heard of it. So I'm super curious about the community. You know, is it large? How do they respond to innovation, so on? You know, maybe this is something that you could show off as well. So I'm super curious about everything.
Yeah, it'd be cool to show it off. So the Hearthstone community, I had it on the first slide, but I glossed over that really quick. It's about 3 to 4 million unique users a month. Hearthstone's a very, very big game. Probably one of the top on Twitch, like top 20. So it's fairly large. I would love to show it off to them. I would like to implement the cards, like I said earlier before that, because they're used to having hundreds of cards, and I have 30 here. So it's like I have to make sure their simulation matches their game.
Yeah. Shardul here is telling us he's coming through as a player of Hearthstone. So that's a nice, sort of hackathon overlap that we have here. I hope, Shardul, you can give a little bit of feedback to Chris as well. This is nice. Yeah, I'm super curious. I'm really looking forward to see if you can, add more cards and see if people pick it up. It's a new world for me. Thank you so much for this project.
Yeah, thank you for the questions.
Okay, any other questions? Doesn't appear so. So I would like to, thank you for the awesome presentation, and then we can move on to Adam, showcasing his WSL provider, if he's ready. Are you here, Adam?
Looks like you unmuted your mic, but we can't hear you in case you're trying to come through.
Can you type in the chat if you can hear us?
Sorry about that. I was talking with my mute button.
Yeah. There we go.
Happens all the time.
All good.
So yeah, I had a bunch of technical difficulties getting in, and then of course it was one of those days at work where I just couldn't get out of work, so I was running late to get here. And then I get here and find out that I had some ESXi problems, and I actually had to rebuild my environment, which means I lost the VM that I had for this. So we're going to go with plan B, and I'm going to present my actual presentation, which has the demo video built into it. So we're still going to be okay. So let me share my screen here. Let's see. Okay. And we're going to go here. Okay, there we go. Should be showing up. So yeah, I have a background as an IT infrastructure engineer. Now, I'm not a coder. I can't code my way out of a paper bag, but I can make things work and I can teach people how to use them. So the purpose of this is I wanted to come up with something that would help standardize the way that we deploy providers. There's a lot of people that have a lot of questions on how to do this, how to do that, why isn't this working, why isn't that working? So I wanted to try to get rid of that as much as possible. And I figured if I can figure out how to do it, then I can document how to do it, and other people can do it. I also submitted a straight up Linux build, but there are tons of people that don't use Linux as their primary OS. So I wanted to build this on top of Windows. People told me it couldn't be done. It's not possible. And as an infrastructure engineer, that's the last thing you want to tell me, because I'm going to stay up day and night till I figure it out. And that's what I did. So the objective was to get the provider installed on Windows inside the Linux subsystem kernel. Benefits of that is going to reduce the barrier to entry of setting up a provider. Once you're in, there's only a couple little things to do and you're up and rolling. I think I got it down to like 10 or 11 steps. Now, the reason everybody said this was impossible that I figured out was on the Windows 10 general release, it is actually not possible to do. When Microsoft has it blocked where you can't run the right kernel. So the way around that is you subscribe to the Windows 10 Insider Preview. Once you're in the dev channel, you can download that. There's also a subsystem for Linux update that you need to apply, and then you can make everything work. So took about 60 hours of research to find a 3-minute fix, as usual. That's what happens when you're in this field. So basically, I'm going to run through the instructions real quick. It's pretty straightforward. You download the dev channel build of Windows 10. You install that as normal. I recommend doing it in a VM. That way it's non-destructive to your machine that you're using, but you can also do it on a physical machine. Just be aware that it is a dev build and you may experience some data loss. So that's why I do everything in VMs, because I just build a VM. If it dies, it dies. I don't care about it. I can rebuild it in about 10 minutes. You do want to make sure all the virtualization features are turned on. That way you can nest the virtualization and get KVM running. That was the biggest problem with making it work, is in the GA releases of Windows 10 that are out in the wild, you cannot get KVM to work. So that was the hurdle that we had to get past. So then you're going to download and install the subsystem. You're going to download the update. And then all you need to do is you set your default to version 2, which is the updated kernel, which allows you to run KVM. You grab the Ubuntu 2004 download, install it. When it's complete, you simply launch it, and then you get to the prompt. Once you're done there, you enter uname -a to verify which kernel you're on. It should report that you're using 5.4.72.
Sorry, Adam, just to interrupt. Are you trying to share your screen at the same time?
Install CPU checker, install ACLs, and then you're going to run KVM OK to make sure that KVM exists, and it should tell you that KVM acceleration can be used. So once you get to that screen, you know you're good. Beyond that, if it doesn't exist and it says you cannot use it, I actually grabbed the shell script straight from the Golem network site. You need to set that as an executable. Then you just simply run the KVM setup, and then you'll run the KVM OK command again. Make sure that you're golden. Once that's done, you can download the provider. I included my mostly automated Linux provider, but you can also use the standard provider that's on the network website. So with that, I do have it working here. I need to move my screen down a hair, I think. Let's see. I might need to shrink it a little bit. Yeah, I do, because what I have to do is fast forward a little bit, because this video is like 35 minutes long. I don't think we want to do that. So let me try to get the bar here. It's just not the right size.
Can you hear me, Adam? Hello? Oh, there we go.
No, that's not working either. So what it's doing right now is it's doing the unpack of the upgrade. And then once you're done, you need to reboot it. So we're going to let that run for a moment. That wasn't helpful. And this takes probably 15 or 20 minutes to get everything done. It's really not that involved. It seems more complicated than it really is. Okay, so now we have our prompt. And we're running through. There we go. uname-a. We got the 5.4.72 build, WSL2. That's the version 2 that I was talking about. And the next step is we're going to install CPU checker. ACL. And from here, I'm just on my GitHub page, copy and pasting commands in, so I didn't have to type them all out. It was supposed to be faster, but it actually took longer. There we go. And we're done. So now we just run kvm OK. KVM exists. Can use KVM acceleration for nested virtualization, and we're good. So at this point, all we need to do is install the provider and get it running. There we go. I don't know why I decided to repeat that. Apologize for that. So at this point, we are ready to download the provider. And it's actually a good thing I did this, because when I installed my automated build on WSL, I actually got a bunch of errors I had to troubleshoot. So I went through those in the video in the live, so you can kind of learn how to get around certain things so they work. So yeah, at this point, I'm just downloading the provider to the Windows VM. Just grab the zip, drop it in, and run it. I really wish it would let me skip through, but it does not have the... There we go. So we're just going to copy a couple things over. Really? It's not being shared. All right. Let me fix that. Okay. And we're going to go here. Okay. Now I think we got it.
It's
Can
still
everybody see
not
now?
being
Sorry about
shared.
that.
Can you hear me, Adam?
So at this point, we're just copying some files over. We got to stick it in a certain location to where we can get to it from the subsystem. So right now I'm just digging through the file system to get to those files to where we can install the provider. There we go. Finally got to it. So now we're setting the scripts as executables so that we can run them. So we need to modify the Golem SP service file that we're going to stick in systemd so that it'll start as a service. If we need to reboot the machine, it'll automatically start up. So there's a couple lines that you need to edit. Basically, you need to put the username in a couple different places. So now we're actually copying that into the system directory of systemd, and I forgot to sudo it. So we're going to do it again. Just making sure the service file's there. And I don't remember if I caught it then, but now I'm looking, I made that an executable and it didn't need to be. I'm not sure if I went back and fixed it or not. I think at this point I was just making silly mistakes because it was about 3 o'clock in the morning and I was trying to get everything done and my eyes were crossed and I just had that feeling where, oh my God, I'm going to fall asleep like right now. So what I was trying to get to is the actual shell script. This makes me really wish I still had that VM because I would just drop right into it and have it done in about 5 minutes. And after about 5 minutes of fiddling around, I finally found it. So now we're actually going to download the provider, install a couple things. So this actually kind of segues into my Linux build. I actually copied this over and was trying to run it. And I did run into a couple things I had to fix, but all in all, it was pretty smooth. And it actually worked the first time. I was pretty amazed. So we go through the setup. I just put some default things in here. There was no reason to put my wallet address and go through all that. So I believe I just defaulted through, yeah. So the step it's on right now, it actually installs something called NetData, which is it's almost like Prometheus and Grafana, but it actually is a little bit simpler to use. There's really not much configuration you need to do. But it takes about 10 minutes to install, so I'm pretty sure I just skipped right through this. If not, I'll go ahead and do that now. Nope, still waiting. Let's see, there we go. So I just buzz forward just a little bit. And this is just me not realizing that I'm not at a shell prompt. I'm trying to finish up the install and I'm typing commands in. So of course that's not going to work. Pretty sure I selected no on this one. All right, let's get to the meat and potatoes. Oops, there we go. So when I got all done, everything was installed. I thought it was done, but I had an issue where I didn't realize it at the time, but a simple reboot would have fixed it. It couldn't find the provider command because for whatever reason it wasn't exported to the shell. So at this point I just grabbed the default installer from the website and ran it. Dump that in there. Yeah, just defaulted through everything. Yep, I just needed to export the paths. I think by now it was about 4 o'clock in the morning, so I was really struggling by this point. But we were so close to the end. I wanted to get it done. So at this point, I'm just making sure that the provider actually exists in the correct folders. Since it wasn't working before, I just wanted to make sure it was installed. So there's the globals and the presets. Now we're going back. I have no idea what I was doing here. This is kind of comical to watch in hindsight. There we go. All right, so at that point, it's running. And so what I did from there is opened up a PowerShell window. Since we're in Windows, we can actually run the Linux command from within PowerShell. I don't remember what I was doing at this point. There was something I was looking for, but I don't remember off the top of my head what it was. Okay, yep, I got the KVM error. So at that point, now it's running. And we're going to go into another instance. And we're going to pull the status just to make sure it's running. So the way I do that, I actually run a watch command. That way I don't have to constantly run the command over and over. It just does it for me. Now the default with that is it'll pull it every 2 seconds. Okay, so at this point, I managed to break it. Just wasn't fully loaded at that point. So here it's running. I let it run overnight. It did complete some jobs. This was back in the 064 days when payments weren't going through. I was having a lot of HTTP errors, trying to unsubscribe and resubscribe, but the provider itself was working. So at this point, all you need to do is sit back, relax, and let the provider do the rest for you. So pending any questions, that's all I have for the group.
Okay, so I'm just gonna test out. Can you hear me? I don't think you can. I'll type in the chat and see. I'll give it a few seconds to see if you notice.
Sorry, I had the speakers muted because I was getting a lot of feedback. Can you repeat, please?
Can you hear me now?
I can.
Okay, perfect. Okay, so although we had some issues with the presentation not being visible, I still want to thank you for presenting here today. I also have a few questions for you.
Okay.
So, since you're the Golem community's server farm freak, do you find do you find it easier to run Golem using WSL or using one of your normal methods? Or
Honestly, it is 100 times easier on just a standard Linux build. One thing I've noticed is the version from the Microsoft Store doesn't appear to be a full version. So that was part of the issues I was having. But yeah, I have much better luck with my VMs. Matter of fact,
okay. So
pop into EXI here and see how they're doing. Can you guys see my screen okay?
oh, we don't see it.
That's really weird. I don't know why it's not showing.
Not sure either, but
How about that?
Nope, still nothing.
Huh.
But I guess we can still continue anyway. So
Okay. Yeah,
so...
sorry about that. I have no idea why it's not presenting. I hit the share my screen.
No worries. It can happen.
It's showing up in the meeting as though it's sharing.
Oh, that's weird. It's just not visible for any of us. So
My apologies.
No worries. My second question is, do you see WSL as a future gateway for Windows users to join the network as a provider, or do you think...
I do.
You do?
I do. Yes. Now, so I maintain everything that I'm working on, and I'm constantly, asking people for feedback, making updates and changes, always trying to make it better, because when people start having problems, they start getting frustrated and they give up, and then they decide that that the juice isn't worth the squeeze for them. So I try to make things as easy as I can and continually update and improve, because nobody's perfect. I mean, I made plenty of mistakes, but at the end of the day, if I can make it easier on people, that's my ultimate goal.
That's very nice. So yeah, I also personally see WSL as a huge thing for Golem in the future. But I think the biggest hurdle right now is that you need to be on the insider build. But when
Yeah,
you
that is an issue. I struggled with it for about 4 to 5 days on my personal desktop, and it refuses to work. I actually had to go in and build the kernel from scratch because it didn't exist. So even after doing all that and countless hours of pulling what hair I have left out, I discovered that the only way it's going to work right now is with one of the insider builds, and I hope that when this dev build goes public and is released as general availability, that it will be included and it'll be much easier for everybody instead of having to run a dev build that that by itself could break.
Indeed. And I can see in the chat that we have a question from one from the community. It basically says, "What do you think are the essential steps for wide adoption of Golem once it goes mainnet?" We are on mainnet, so that's a little bit confusing. I guess we can we can skip that question maybe. Yeah, there's not any more question from my side, so I'm wondering if anyone else in here has any questions. Nope, doesn't look like it. So I want to thank you once again for presenting, Adam. Much appreciated.
Or
And,
trying to.
Yeah, well, we managed
Again,
to.
I have no idea why it wasn't presenting. I thought it was presenting the whole time, and I like I said, had the speakers muted, so I didn't get feedback and make it miserable for everybody. So my apologies.
Don't worry about it. Don't worry about it. It can happen for all of us. So, but without further ado, then I will pass over the word to Matthias, who's going to wrap this up.
Yeah, so thank you for the cool questions, and thank you, Shadul and Chris and Adam for joining and coming to present. It was really fun to learn a bit more about the projects and just get some thoughts about how it was built and what you guys focused on during your hackathon. And with that, I would also like to invite you guys to hopefully join at the next hackathon that's coming up, which is OX Hack. I can put the link in the chat. I'll also put it on the YouTube. So we're collaborating with a few different projects. So the hackathon that just passed was mainly us, but it was kind of part of a wider hackathon. But this is OX Hack, which is more directly collaborating with other sponsors. So the other sponsors for the upcoming hackathon are Polygon, Status, ETHWorks. There's also Ethereum Foundation, ENS, Chainlink, Starkware, and media partners, which is CryptoDev and Suzurmik Bitcoiner, I think it's pronounced. I might be wrong on that one, but I just hope to invite everyone that's watching and everyone that's joined previous hackathons to come join in and have some fun with hacking and maybe discussing some of the other projects and doing a bit of collaboration. So we look forward to seeing you there, and thanks again for joining, and thanks for everyone watching the live stream. And I think that's it. So bye, everyone.
Yeah,
We'll see you next time.
Yeah.
All
Thank
right,
you.
everybody. Well, thank you for inviting me and having me, and I will be in the next one.
For sure.
Yay.
Always improving.
Thank you so much. Bye.
Sounds great.
Thank you. You guys have a good
Thank
rest of your
you.
day.